Problem 68, text justification. So we are given an array of strings. The array is called words. So array of strings. And we're given an integer called max width. We are asked to format the text such that each line has exactly max width characters and is fully left and right justified. Okay, so imagine basically being given an array of strings. Well, imagine each of these words being a separate string inside an array. Right? So these are indices. I put string with index 0, that's science. String with index 1 is this word here, is, and so on. So these are all separate strings. And then we're given this max width integer. And we have to produce something you see down here, right? So this the output is basically an array of strings. So this is an array, and each element is a string. And each string has 20 characters, as we're given max width is 20. And that also includes the last line. It also must have exactly max width number of characters. And then they just give you the rules, how they want you to justify these lines. You should pack your words in a greedy approach. That is, pack as many words as you can in each line, pad extra spaces when necessary, so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on a line does not divide evenly between words, the empty slots on the left will be assigned more spaces than the slots on the right. Okay, and then for the last line of the text, the last line has slightly different rules. It should be left justified. Okay, and no extra space is inserted between words, although they do insert spaces at the end of the line in case it does not fully amount to the required length, right? So, but they do ask you not to add any extra spaces in between the words on the last line, right? So do not add any additional spaces on the last line between the words, but we can, as you can see from this example, we can add spaces at the end of the line. Now, you can also see that on all of the other lines, other than the last line, if you can pack at least 2 words, right, then there will be no extra spaces at the end of the line. But in this case, as you can see, if only 1 word can be fitted on a line, then any extra spaces, any extra required spaces will be added after the word, not before the word, okay? So every line always starts with a non-space character, with a letter, let's say. Every line always starts with a letter, and it may not end with a letter. It may end with a space, okay? Okay, so we'll have to take that into consideration. We are given some assurances, restrictions. A word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not to exceed max width. Okay, so each word will not exceed the line or the width of the line, so we don't have to do any truncate, whatever it's called, hyphenation. The input array words contains at least 1 word. So the input array words will contain at least 1 word. Okay. Let's think about the solution now. The first thing I'm going to do is I'm not going to edit this program in the simplistic editor, which LeetCode provides. It's missing a lot of functionality. For example, there is no IntelliSense. Also, it doesn't give me any errors until I try to run this program, which is not good enough. I think for a moderately complex problem like this, I want to use something like a slightly better editor. So why don't we go to typescriptlang.org, and here is a playground, TypeScript playground. So we can just click on this playground link, clean this screen, and just copy over this function signature over to the TypeScript playground, right? Now, we are asked to write this function here, fullJustify. The input is what? Array of strings and an integer, which would be the maximum width of a string. And we have to return, as you remember, array of strings. So before we start writing this function, I think it's best to think about what sort of other functions we might require, right? And the kind of fundamental kind of function, fundamental type of logic, which I'm going to put into a separate function, seems to be the following. I mean, let's say we've taken care of already some part of the sentence. Let's say this is already taken care of. So my function would take this starting index of the first word that hasn't been taken care of. It will also take this marked widths, obviously, and this array and all of this. And what it would return is it would tell me how many words fit on the next line. So it would give me the end, the index of the first word that is no longer part of this line. Okay, so instead of returning the index of the last word on this line, I'm going to return an exclusive end. So the basically one next. This is often useful, right? For example, the loops will be very similar to when you have the length of the array, which is kind of index of the. We often run the loop till the length of the array, right? But we kind of consider that to be index of the one element next after the array, kind of. So it's useful to have that sort of a mindset, to keep that sort of mindset. So I will return this exclusive end, okay? I'm going to call this function readLine. Okay, so readLine returns what? Returns the exclusive end, so some sort of index of an element inside the original array. Do I need anything else? So probably I will, okay, min width, and I'll explain to you what I mean by this. So min width will be kind of, we have this max width given, right? It will be a related number, I think, because this will be the length of this string, right? If you choose all of these words, all the way from the start to end, well, exclusive end. If you choose all of these words and add only a single space between the words and nowhere else, no spaces at the end or anywhere, just single space between the words, that would be the minimum width of this line, right? So we obviously may have to add some extra spaces to take it all the way to the max width, but the minimum width of this line would be whatever I want to return. And the reason why I want to return this is because obviously I have to count that while calculating where the line should end. Basically, I will be looking at this sort of min width, right? Because if this word would still fit with a single space, with this min width, if I can add one more word, then obviously this word would also be included in the line. The only way for me to decide that this next word doesn't actually fit is for me to keep track of this min width. So I have to keep track of the min width. And why I want to return it from this function, because I will need it later in the next function, right? So readLine, let's write its signature first. So I am going to have some sort of function called readLine. And this function, as we said, will return the last index, which will be number, and min width, which will also be a number. In terms of what I'm going to give it to it, I'm going to give it to it words, the original array. Let's give it the starting index and max width, which is a number. So this is my first function, okay, that I'm going to write, readLine. It returns, you know what, I don't like this kind of squiggly red squiggles here, so I'm going to say just to get rid of the squiggles. Hopefully I'll remember this one, return an empty string. Oh, just return an empty array here. So we have, this will be the basic, the underlying fundamental kind of function. The next one will be justifyLine. Function justifyLine. So justifyLine will return a string. So it will basically return a single line here, but it will be for all of these lines other than the last line. So not the last one, not the last line, okay? So what would that need? This will need words, the original array. So I'm not going to mutate the original array at all. So it would need a start number, right? So, and then end, which is also a number. And this end will come from this function here, from the previous function, okay? So let me just clean this up a little bit. So we have this readLine already. We did the readLine function. Well, we didn't write it. We just came up with its signature. And this one, basically, I need a beginning, the first character. As we said, an exclusive end. So it defines the line like this. Now, we also said, so start, exclusive end, and min width and max width. We need that, right? We need min width and max width. So min width, that would be a number, and max width, which is also a number. So we will use that. I mean, obviously, max width is required because we need to know. Basically, what we'll be doing, we'll be taking the strings here and we'll be turning them into a single string and adding the required number of spaces everywhere, including at the end, potentially. Well, if it's a single word, we said. So if it's a single word and it still needs some empty spaces at the end, we'll do that. So all of this will be done in this function, justifyLine. So this is for all of these lines here, except for the last one, okay? Yeah, and it returns a string. Again, let me put some sort of dummy return empty string. I will also need function justifyLastLine. Okay. Now this will also return a string. Sorry, I will need these functions to kind of compile, because I'll be running some of them, probably testing them as we go along, because I'm not going to write the entire program and then just hope that it will magically work. I'll be probably testing each of these functions separately. JustifyLastLine. Again, it should return a string of a specific length, the same max width length. It will need words. It will need start. No end, because end would be all of the words inside the original array called words. All of the words starting from the start and all the way to the end. But max width will be required. Okay. So you see that I'm kind of I am giving all of these required parameters to every function. This is, say, for example, this array. I'm not going to be copying this over, obviously. It's just being passed around as a reference. But you probably notice that I'm writing pure functions, right? So these will be pure functions. It's not going to be some sort of global words array, and then I could access it from everywhere. Also, you can probably see that I'm not slicing this array. So you could just, to each of these functions, give a slice, a portion of the array that is required. But probably for memory efficiency, I'll just do it like this, right? So I'll be dealing with start and end were required to just denote which segment, which portion of the array needs to be worked on, okay? Right, so I think that's it. These are the main functions that I will be writing. So now we can probably start writing one of them. Let's start from some easy wins here. I think this is the easiest one to tackle. In fact, this is so easy. I mean, I'm not even going to spend any serious time on these words. Let's just slice from start and all the way to the end. And I said I'm not going to slice arrays around, but this is so simple. I mean, if anybody wants to make this slightly more efficient, but I mean, this will be fast enough. It will just take slightly more memory and whatever, but then join it with a single space. So we take all of the necessary words with a slice, then we'll join them up with a single space, and then head end with until max width, right? And that's it. That's this function right there. The next function I want to tackle is justifyLine, right? Because we just did justifyLastLine, so this is not very similar, but in terms of implementation, this will be slightly more complicated, but at least in concept. And the way I'm going to format the signature, just bear with me for a second. I do this often because there are too many input parameters here. Right, so justifyLine, correct? So we're going to be dealing with all of these lines now. So we've dealt with the very last line. Where is it? So we've dealt with the very last line, but now we need to deal with all of the other lines other than the last, right? And here we have the following inputs, right? We have the start, right? We have the start. We have an exclusive end, which basically defines for us the line, all of the words that will be joined together into a line. Yes. And we have min width and max width, right? These are our inputs. Now, the first thing to do here is basically we need number of gaps. right? Number of gaps. And the number of gaps would be end minus start and -1. So end minus start is the number of words, and -1 gives you the number of gaps, right? Just to quickly test this, imagine there is just a single word. Yeah, let's say we only have this single word. In that case, end points to the very next word. So, and 5 minus 4 is 1, -1 is 0. So that gives you 0 gaps, which is precisely correct. If you have just one word, then you have 0 gaps between words, right? So hopefully we trust each other that that's the number of gaps we're going to have, right? That's the number of gaps. Now, if we have that many gaps, that means we may have to inject some additional spaces in here. Now, how many spaces should we inject? Now, remember that mean width is the width if we injected only a single space. Now, remember, we haven't really injected any of the spaces anywhere, but mean width is just how wide this line would be if only a single space were to be injected into every gap between the words, right? So do we need to inject any more? Well, the total size is max width. So why don't we take max width, right? Subtract mean width, and then divide it by the number of gaps, right? So end minus start -1. Now, if we make this division, that should give you, if you take the floor here, right, that will give you the base number of spaces. Actually, one more, right? Because mean width already contains, mean width was calculated when we already had imagined a single space between every word, right? So this will give us additional spaces to 1. But the total would be 1 plus that additional number of spaces, right? And then a few spaces in the beginning will have still one more space, right? So for example, but before we talk about that, let's notice that this thing must be positive, right? It cannot be 0. It should never be negative, obviously. But if this is 0, that's a valid situation. So that means you have one word. If you have just one word, then number of gaps is 0, and we have to, and basically this whole algorithm that I'm building here are going to fail. So I'm going to handle this differently. So why don't I do that so that I don't forget it? Why don't I handle this edge case if start plus 1 precisely equals end? That's our edge case, which means we only have words start, correct? Just a single word. And I could just return that single word padded in the end with required number of spaces to take it all the way to max width, right? So with this statement, I've handled this edge case when there is just single word. But why don't I also handle just every other weird situation? So if start is somehow greater or equal to the end, then throw new error, just something like start and end are invalid. This may be useful for me during testing because I should never call this function without any number of words, without 0 words, so when these are equal, or negative number of words when start is actually greater than end. So this is just some sort of precaution. This is an actual edge case that we've handled, correct? Now, also, let's say constant number of gaps equals, and I think, so what I'm going to do, just you remember, I'm just going to do this little thing here, right? Yeah, this little thing. It's not very little, but so 1 plus, and then math floor. Should I do math floor? Just 1 second. So then I will do max width minus min width, and I'm gonna divide this by and minus excuse me, start minus 1. And I could, instead of max math floor, I could just do this binary shift by 0, which will basically do exactly what I need. But I'm not going to do either, because I think the way I'm going to be using this gaps, it won't matter that it has a fraction at the end. It will be discarded anyway. So I'm just not going to bother with that. So this could potentially be a fraction, but say in other languages where you have integer division, this could be an integer division. So I'm going to pretend this is an integer division, which it is not. But it will still work in JavaScript, because the way I'm going to be using it, I kind of already predict how I'm going to be using this. The way I'm going to be using this, well, we first have to say a couple of other things. So remember we said a few gaps in the beginning will have an extra space. So still one more space than this, okay? One more space than that. How many of these will be there? And I think you can guess it will be the remainder of this division. So when we take this division, there will be a remainder. There might be a remainder, non-zero. It will be less than the number of gaps, definitely strictly less than the number of gaps. So we can distribute 1 extra space per gap. We can definitely do that, because there will be more gaps than the remainder. So we can put 1 extra space in these few initial gaps. This is what they've told us in the problem description, right? If you remember. That all of the extra space, so the spaces should be distributed as evenly as possible, they said. And if you can't do that, then slightly more spaces you can have in the beginning. Something like that, they told us. So if I take this remainder, if I calculate this remainder, then the first R gaps would be one more than this number, okay? So why don't I just calculate this remainder, which is max width minus min width, and remainder and minus start minus 1. Okay, that's the remainder. Now, let's start building our line. Okay, I'm going to return this line. And to build this line, I cannot start with an empty line, with an empty string. That's not a good idea, okay? What I'm going to do is I'm going to start from words start, right? Let me explain why I'm going to do this. So if this is your words, right? Start and end. Then in terms of adding gaps, you have to think that they belong after a word, right? So this gap belongs with this word here, or this gap belongs with this word, right? So now I want to add every gap after a word. So I'm going to add, I'm going to add it before the word, yeah? Before the word is better. So every time I'm going to add a word, I'm going to say add the required number of gaps and then also add a word. Again, gap and a word, gap and a word. That's what I'm going to do in the loop, right? Now, why not do it like this. Because in this case, I mean, either way you do it, whether you attribute gaps before the word, which I'm going to do, or after the word, you're going to have a special case. So either the first word will be a special because it doesn't have anything before, or the last word will be a special case because last word doesn't have any gaps at the end, right? Remember, by the way, that we've already handled this extra special case when you have just one word. When you have one word, you may have spaces at the end, but not in this case. That's already handled. So we have at least one gap now. So no spaces at the end. So either way you do it, you're going to have a special case. And I'd rather have a special case in the beginning, yeah? Because I know where the beginning is and end could be, I mean, it's easier for me to do this in the beginning. And the way, why this is easier, I mean, I could start with this word without adding an empty space during the initialization, right? That's what I did. So now that I did this, say, for example, so I didn't do this, right? I didn't do this. So that means my initialization took care of not adding that extra space before. So I've already handled this special case. I have to initialize line somehow. So why don't I just initialize it correctly without the leading gap, right? Now I can do a loop, right? And this loop would be, let I be start plus 1, okay? Because I'm going to add a word at this index. I is less than or equal to start plus R and plus I. So just to check this, the logic, obviously the start is correct because we already added word start. Now we're going to add word start plus 1. If R is 0, then this shouldn't run at all, which is correct. We start at start plus 1 and at start plus 0, so this will not run. If it's 1, this will only run once, which is correct. So that sounds great. So line plus equals to specific number of gaps, 1 plus gaps, yeah? And then plus words start. Make sense? I think it made sense, right? Line plus space repeated one more time than gaps, because remember, this is the reminder that we're dealing here. So one more than gaps. And word, sorry, that's not correct. Words I. Okay, any other goofy mistakes? Or now let's deal with normal gaps where we do not need this extra space. And that should start from start plus R plus 1, correct? Because we already handled start plus R. That is already there. So now we need start plus R plus 1. Obviously, plus I. And this line will be very similar. So repeat, but just gaps, not 1 plus gaps. That will be the only difference. So the only difference here is instead of 1 plus gaps, it's just gaps, right? So these two loops, sorry, what's going on here? Right. I is less than end, right? Yeah, so I is less than end, plus I. Hopefully I didn't do something completely stupid, which is easy to do when you're talking and commenting. I mean, for me, it's easy to do anyway, but I can do it anytime. Goofy mistake. But this should be our function. Why don't we just quickly test it? So to quickly test this thing, let's create words array. I want to go to school every day. That's my words array. Start be 0. and be, let's say, some number, constant min width will be something that I'll calculate in a second. Constant max width be, let's say, 20, right? And then line will be justifyLine, words, start, and exclusive end, right? Min width, max width. And why don't I console clear here, console log line length, just to make sure that, and then the line itself. Yeah, so that's what I'm going to do. Just need min width. I don't want to calculate it manually. So let's say words slice from start to end, and slice takes exclusive end as well. So, and then let's reduce it. And here I'm going to do something simple, right? So I'm going to say the min width that we're trying to calculate and the next word. And what I want to do is something like min width plus 1 plus word length. Now, this isn't really always correct. This 1 would be for every word except for the first one. But you know what I can do is, because this, if I start from -1, because I know already that this will have at least one word, every other time this will throw an error, right? Remember, this throws an error unless you have at least one word. One word is handled as a valid case, but if you don't have at least one word, this will throw an error. So we're protected there. So if I start from -1, that will cancel the extra kind of space that I will count before the first word, right? Okay, so I want 2. So we said 3 means, yeah, so 3 is this. So that's the exclusive end means I want 2, and it was correctly added to 20 characters and whatever. Hopefully this is also correct, yeah? What if I do 4? I want to go, okay, that's 4 words. What if I start from the slightly still? So see, this remains 20. It seems to be fine. So I like this function. I think, can I give it some nonsensical stuff? So max width, make it 2000. Oh, what happened? 2000. Okay, no, I just didn't press run apparently. So it seems to be still fine. Yeah, the length is 2000. It ends without a space. Okay, what if we need one word? So n will be 2, and instead of 2000, let's say 10. Yeah, and it added correct number of spaces in the end. That's this special case here. Okay, so let's say we've tested this function. Okay, get rid of the test. And you know what? I'm going to fold these functions that I've written. This is probably correct. I'm not going to even... And obviously now when I say that this will definitely be correct, this is precisely when it will then be not correct. But anyway, I mean, so let's say we have these 2 functions done, and now we need 2 more to go. The next function to tackle is probably readLine. Let's do readLine first. And this one will be quite challenging to get right. I mean, it looks very simple, but I mean, in order to do it properly so that it looks elegant and it handles all the edge cases properly, etc., it's going to be interesting. So start. We take the starting position, and we have to calculate this exclusive end here, which would define our line, right? This would be our line. And we also need to calculate min width. And min width, just to remind ourselves, is the length of the string if we were to add only a single space between every single word. Yeah. So that's what we need to do. Now, to do that, I propose to start like this. So end initially will point to the beginning, to the start, to the same start and end will be the same. That's I'm going to initialize it like that. Which means I am looking at an empty string, right? If the beginning is this word, but also end means it should end before this word, that means there are no words. At this point, min width can be set to be equal to 0. So end is the same as start in the beginning. Min width is 0. But notice what I'm going to do. So before I can increment end, I have to calculate next minimum width. So initially my kind of line is empty. It's this. It starts here and ends here. So, but if I were to move end here, that would mean now this would be my line. But before I can do that, I have to ensure that this next min width is still less than or equal to max width, right? So, you know what? I'm going to have next min width, right? How do I initialize it? Well, because initially I have an empty line, nothing, my next min width will be the length of the first word. So word start and no leading space, okay? So that would also kind of take care of the special case, the very first word being a special case because it does not have leading empty space, because every other word will have a leading empty space except for the first one. So by calculating this next min width outside of the loop, before the loop, because the loop will come later here. So I have already incorporated this special case of the first word not having the leading space. So the body of the loop doesn't have to be, there should not be any checking whether I'm looking at the first word or not, which is ugly. So let's initialize, let's do that bit first. Right? So what I'm going to do is, what did we say? Let's create end, which will be set to start. And then let's create min width and set it to 0. And let's create next min width and we'll set it to word start length, right? And now we need a loop. And a kind of logical loop would be a while loop where, I mean, next min width, while next min width does not exceed max width, right? That means that our line is valid. So while our line is valid and our future line is valid, right? While our future line is valid, that's what next min width means. That means we could increment end because next min width is the width. If we were to increment end, then the future line would still be valid, so we must increment end, okay? The other thing we should do, I mean, as soon as we increment end, we should recalculate min width and next min width, right? So obviously min width will be next min width. That is correct. And now we have to recalculate next min width. And herein lies a little kind of trouble. I mean, if we were just to do next min width equals what? We have to add the length of the next word. And next word is obviously end. End is already been incremented. And this will now be pointing to the next word, which we haven't actually counted yet, right? But that's the job of next min width. It should say words end, because that's an exclusive end, dot length, but also one space in the beginning, right? So we would add one space to every word except for first. Remember that. But that's taken care of, right? So this is very similar to this, except there is no 1+ here. So that's where we handled the special case of the first word. But every other word, starting from, after the first word, will have this precisely one space for calculating min width. But here's the trouble. I mean, we've incremented end, and in normal loops, we usually somehow have within the body, we ensure that this does not kind of go over outside of this array, but potentially we could go over the array here, right? So we would not go over the array here, right? I mean, hopefully this start index is correct. We could put some sort of if whatever start is greater or equal to words length, then we could throw new error and valid start. Okay. I mean, we could do that if you want. This will, we won't call it like this. We will never use start to be pointing outside of the array. So this is valid. And the first time we enter here, I mean, we could already go over the end of the array. And if we do, I mean, if suddenly end is equal to, let's write it like this, greater or equal to words length, that means we've exhausted the array, right? Because the next word, we've incremented it, and now the next word is pointing at the end of the array, which is past the last index. So break. There is no need to continue this loop. And now we can return this end. So get rid of this thing. And this min width. Get rid of this. So we can return end and min width. Should we test this readLine? Okay, let's test this readLine. So constant words equals I like coding hard problems elegantly with TypeScript, something like that. Now, what else do we need? We need start. Make it 0 for a second, and max width, make it, let's say, 15. Now, console clear. Line, you know what? But end and min width would be readLine from words, start, and max width. And now we can say console log, and that's horrible. But anyway, let's do it like that. Let's see, let's run this. So I'm saying 15, right? And this gives me end is 3. So 3 words. That's 3 words. So 1, 4, that's 5, 6. 2, 4, 6, 12, 13. So that's 13, correct? And then the next would be 20 with the space 21. So that's that looks fine. That looks correct. So what if I say 3? One word, I, and its minimum width is 1. That's correct. What if we say 5? What if we say 5? So still one word, yeah. Now if I go with 6, not 56, then 2 words and minimum length of this sentence would be I like, which is 6 with a space. That's all good. So what happened with Yeah, no, this seems to be, so if I just put some nonsensical number, just ensure that, yeah, there is no going over the end of the array and some sort of, okay, that sounds fine. And 8 and min width 53, 4, 5, 6, 7, 8. Yeah, so we have 8 words. 1, 2, 3, 4, 5, 6, 7, 8. 8 means it's pointing here. Yeah, 0 based. This is good. All right, so that seems to be correct. So we can collapse this function as well and go to the final function, fullJustify. This is the final price, right? This is the function that will basically take the array of words and max width and return fully justified array of strings. Now, the way to do this, let's say we have start. This is the index of the word that we haven't processed yet. The very first word that needs to be processed, right? The one that we haven't yet justified. And we basically will have a loop, yeah? And within the loop, we'll say while start is still less than words length. So if start is less than words length, which means we still have at least one word to process, right? When start points outside of the array, that means when, that's it, we've exhausted every word. We've processed everything, right? So that's our loop. And inside the loop, we need lines. This will be what we're going to return. This is where we're going to collect the justified lines. So we're going to return these lines, okay? So within this loop, start points to the first word that we haven't processed, we haven't already added inside lines, right? So we would need to readLine, right? We would need to readLine. So words, starting position, and max width. And that would give us the ending position, and min width, right? Now, how can we use this? End and min width. Now, first of all, let's look at the end. So if we're looking at the last line, then we'll use justifyLastLine. Otherwise, we'll use justifyLine, right? So we'll be pushing something. So lines push something, right? But whatever we're pushing will be defined either by justifyLine or justifyLastLine. And to make that decision, right, we could say if end is less than words length, that means, remember, what does that mean? End is the word that we haven't processed yet. This is the index of the word we haven't yet processed. If it's less than length, then this is not the last line. There is at least one word that we haven't processed. Yeah. So that means lines push, and we need justify line, right? It's not the last line, but justify line. Words, start, end, min width, and max width, right? This min width came from here. And else, we can do lines push and justify last line. And here we just need words, start, and max width. Now that I think of it, I think I should have added end as well here. Yeah, I should have added end here. So probably what that would do is start, end, number, and this one would also do like that. Okay, let's fold this back. I mean, this is just for consistency. And for example, if you decide to copy this to C++ or something like that, that would be a better solution. All right, is that, oh, well, no. So we did this, but now start equals end, correct? yeah, that will be, that will take us to the next iteration, right? So start is less than length. So, okay, and then, yeah, so we got the end, and that points to the first word that we haven't processed. We're going to set start to the end. That's correct. At least it should be. Okay, let's quickly check this. Let's create words equals to I like coding beautiful problems in TypeScript, right? Constant max width, make that 20, and line equals, not line, but lines, right? Equals fullJustify words and max width. And now console clear and console log lines. Yeah, it looks horrible. So let's join this with, and maybe also start with, you know what, start with the new line. How about that? So if you look here, right, that looks, maybe also lines, map, take each word, replace with, let's say, every space globally be replaced with what? Let's replace it with some sort of special character here. Okay, yeah, now that looks nice. I like coding beautiful problems in TypeScript. That looks justified, right? So if we make it, let's say 25, so two spaces, single space, one space on the last line, 3 spaces, all looks fine. It's nice. Make it huge number. Okay. I think that's too big, but I mean, just to ensure that this doesn't do something crazy. 10. Yeah. This looks absolutely okay to me. So, okay, let's still fold it. Get rid of these tests. Let's copy this over to our, okay, to LeetCode. Beautiful. Now we can, you know what, let me make it slightly smaller. It's probably slightly more manageable, and run this on our test cases. Keeping fingers crossed. Wow. Okay, everything passed. And now keeping fingers crossed on both hands, right? Both hands, because that's oh, okay. Beats 100% of solutions in terms of speed. That's not too shabby. Well, in terms of memory, we didn't do too well. I mean, again, we didn't really use too much memory here. We didn't create another array. We just created a bunch of functions, a couple of integers. So I'm not, well, only here I'm kind of have a redundant array being created with a slice. So you know what, I'm pretty happy with this result. This 23%, I mean, should be, I keep saying this, but I haven't really tested or checked. I don't know how they calculate this memory usage of JavaScript or TypeScript. You know, is this the entire heap that they are? So I don't know what they're doing, how they're calculating this. So, but this is a decent solution. I mean, this number is quite impressive. So we beat 100% of the solutions in terms of speed, which isn't bad. Okay, decent. That's it. I mean, any final words about this? So what can we say about this implementation? I mean, This is slightly closer to what a developer would do in real life, right? I mean, you would write a whole bunch of comments here, some description of the functions. But in terms of how you would approach it, I mean, the functions are more or less elegant. I mean, this is readable if a new developer, if a different developer has to take this over and change something. I mean, you could still make it slightly more, even better readable and maintainable with more comments. Like, for example, where is the last line? How is the last line handled? Well, it's right here. Maybe give it some parameterized options of, should we pad these extra lines at the end? Maybe this should be an option. Maybe pad them from the beginning. Nobody would ever want that. So we would not have this as an option because that's stupid and would just add nonsensical complexity. So that sort of thing. But I mean, this is how I think a developer would do it. Yeah, this is a decent solution. The only thing you need to add to this is a bunch of comments and make it nicer. And that's it. I mean, that's a solution.